Question 1. From a practical standpoint, Priya's team is integrating an on-premise ERP system with Oracle ERP Cloud. Due to strict firewall rules, outbound calls are restricted. Which connectivity approach should she implement to ensure secure bidirectional communication? A. Use the connectivity agent for outbound initiation from on-premises. B. Implement VPA-based IP whitelisting. C. Configure direct REST API calls to the ERP Cloud without agents. D. Use managed file transfer for message exchange. Answer. Correct answer. A. Explanation. The connectivity agent enables secure communication from on-premises to Oracle Cloud without inbound firewall changes, initiating traffic outbound and supporting bidirectional flows. VPA whitelisting alone doesn't handle protocol conversion or connection management. Direct REST API calls fail due to blocked inbound traffic. MFT is suited for large batch file transfers, not continuous transactional ERP integration. This choice aligns with OIC architecture best practices for hybrid deployments. Question 2. Given the circumstances, an OIC developer notices that a scheduled integration pulling data from an FTP server occasionally fails when the server is temporarily down. What's the most effective fault handling strategy? A. Disable the scheduler until the FTP server is stable. B. Implement fault handler with retry and exponential backoff. C. Use Groovy scripts to bypass file retrieval logic. D. Switch to synchronous integration to avoid scheduling. Answer. Correct answer. B. Explanation. Retry with exponential backoff is a robust fault handling design, reducing load on unavailable services and maximizing success rates without manual intervention. Disabling schedules sacrifices automation. Using Groovy to skip retrieval ignores the core requirement of fetching files. Switching to synchronous mode doesn't address availability issues and adds dependency on constant uptime. This method aligns with a fault handling best practices and resilient integration design principles. Question 3. To illustrate this point, Carlos is building an orchestration that aggregates responses from multiple REST services. Some services are slow, but overall latency must be minimized. Which pattern should he use? A. Parallel processing branches within the orchestration. B. Sequential invoke activities to preserve order. C. Scheduled integration to spread calls over time. D. File-based aggregation after all calls complete. Answer. Correct answer. C. Explanation. Parallel processing in orchestrations reduces total execution time by invoking multiple services concurrently, ideal for latency-sensitive aggregations. Sequential invocation increases latency as each call waits for the prior to finish. Scheduling doesn't help real-time aggregation needs. File-based aggregation introduces unnecessary I/O and is suited for batch data, not synchronous multi-service calls. The method follows OIC orchestration performance optimization guidelines. Question 4. Through careful analysis of error logs, May identifies that certain transformations in OIC integrations fail when source data lacks optional JSON fields. What's the best preventive approach? A. Create custom adapters to handle null inputs. B. Configure conditional mapping expressions in the data mapper. C. Switch all integrations to SOAP to enforce strict schemas. D. Disable validation in the integration settings. Answer. Correct answer. B. Explanation. Conditional mapping expressions allow transformations to handle missing fields gracefully, avoiding runtime errors while preserving integration flexibility. Custom adapters are unnecessary overhead for handling nulls. Forcing SOAP is overkill and reduces agility when JSON REST is sufficient. Disabling validation may let errors propagate downstream, compromising data integrity. Proper mapping logic aligns with data transformation best practices. Question 5. The core principles of API security and OIC dictate that certain integrations require policy enforcement at the entry point. Which configuration best ensures that only authenticated external calls reach the integration? A. Enabling role-based access control in the target application. B. Applying OAuth 2.0 policies in the API gateway. C. Adding a custom header validation in the integration. D. Configuring a connectivity agent to filter requests. Answer. Correct answer. B. Explanation. OAuth 2.0 policies the API gateway ensure authentication before the request even reaches the integration, enforcing centralized security and reducing attack exposure. Role-based access in the target app protects backend access but doesn't stop unauthenticated API calls. Custom header validation is weaker and can be bypassed. Connectivity agent filtering is for on-premise connections, not API traffic control. Question 6. When faced with a need to transform a large XML document into multiple JSON payloads for downstream recipes, which OAuth feature is best suited? A. Use data mapper with for each loops in orchestration. B. Split the XML manually with Groovy scripting only. C. Configure the target adapters to accept XML directly. D. Use scheduled integration with staging tables. Answer. Correct answer. A. Explanation. The data mapper with for each loop sufficiently transforms and iterates through XML nodes, producing multiple JSON outputs within orchestration flows. Manual Groovy scripting increases complexity and maintenance cost. Target adapters may not accept XML directly if they are REST-based. Staging tables suit batch processing but add latency and storage dependencies. This approach leverages OAuth's build, transformation, and looping capabilities for optimal performance. Question 7. In the modern context of hybrid integrations lies company wants to maintain lookup tables that map customer categories between on-premise ERM and Oracle Sales Cloud, which approach minimizes manual updates. A. Hardcode mapping boundaries inside the integration. B. Use OAuth lookups with centralized management. C. Store mappings in an external flat file. D. Maintain mappings in the target application's metadata. Answer. Correct answer. B. Explanation. OAuth lookups centralize mapping logic, making updates easy without redeploying integrations, ensuring consistency across flows. Hardcoding values forces redeployment for changes. Flat files introduce version control and access complexities. Target application metadata may not support all required mapping permutations. OAuth lookups align with best practices for maintainability and governance in integration solutions. Question 8. Contrary to popular belief, switching an integration from synchronous to asynchronous always improves performance. Which scenario proves this assumption wrong? A. A long-running order processing workflow requiring intermediate persistence. B. A high-frequency real-time API expecting immediate client responses. C. A batch file ingestion with delayed downstream processing. D. An integration requiring retry mechanisms for external calls. Answer. Correct answer. B. Explanation. High-frequency real-time APIs require immediate responses, making synchronous processing essential for meeting slots. Asynchronous flows introduce queuing delays, degrading responsiveness. Long-running workflows benefit from async to avoid timeouts. Batch file ingestion also suits async. Retry mechanisms can be embedded in either pattern. This highlights the need to choose patterns based on functional requirements. Question 9. The underlying principle of monitoring in OAuth is not just to detect errors but also to optimize performance. Which tool or feature supports both? A. Audit logs from the target application. B. OAuth integration inside dashboards. C. Manual log passing from the connectivity agent. D. Static code review of orchestration flows. Answer. Correct answer. D. Explanation. Integration Insight provides KPIS tracking business transactions for both error detection and performance optimization. Target app audit logs only show downstream activity. Connectivity agent logs focus on connectivity, not end-to-end performance. Static code review improves quality but doesn't offer live performance analytics. Insight aligns with proactive monitoring and optimization strategies in OAuth. Question 10. In light of recent developments, a new compliance policy requires encrypting all files transferred via OAuth integrations. Which implementation meets this requirement without major redesign? A. Modify integrations to apply encryption logic in Groovy before transfer. B. Use BILIPGP encryption with the FTP adapter. C. Transfer files via email with password-protected zips. D. Store files temporarily in encrypted cloud object storage. Answer. Correct answer. D. Explanation. BIL and PGP encryption in the FTP adapter is a native low-overhead solution meeting compliance without major redesign. Groovy-based encryption is possible but increases complexity and risks inconsistencies. Email transfer with password-protected zips is less secure and not enterprise-grade. Storing in encrypted object storage may not cover in-transit encryption requirements. This approach adheres to OAK security policy integration best practices. Question 11. Throughout the course of integrating a payroll system with Oracle HCM Cloud, AMED must ensure that sensitive employee data sent via REST is protected both in transit and at rest. What's the most secure and efficient approach? A. Apply OAuth 2.0 with TLS for REST calls. B. Use basic authentication with strong passwords. C. Send data in plain text over TLS. D. Encrypt data at rest only. Answer. Correct answer. A. Explanation. OAuth 2.0 with TLS secures authentication and encrypts data in transit, meeting both security and compliance standards. Basic authentication, even with strong passwords, is less secure due to static credentials. Plain text over TLS is contradictory. HTTPS already encrypts, but without authentication, it's incomplete. Encrypting data at rest alone ignores transit risks. OAK best practices recommend OAuth with TLS for REST integrations handling sensitive data. Question 12. When considering integration patterns, which scenario is best suited for a scheduled integration? A. Processing real-time payment authorizations. B. Synchronizing daily inventory data between ERP and warehouse systems. C. Handling synchronous API requests from a mobile app. D. Orchestrating concurrent service calls for aggregated responses. Answer. Correct answer. B. Explanation. Scheduled integrations excel in batch operations like daily inventory syncs where real-time updates are unnecessary. Real-time payments require immediate synchronous flows. Mobile API calls demand low-latency synchronous execution. Concurrent service calls for aggregation are better suited for parallel orchestration patterns. Scheduling reduces resource usage while ensuring predictable execution, aligning with OAK efficiency guidelines. Question 13. Taking into account deployment processes, SOFIA needs to migrate an integration from test to production while preserving endpoint configurations. Which method ensures this with minimal manual changes? A. Export-import integration and reconfigure endpoints manually. B. Use connection properties and variable substitution during deployment. C. Create a duplicate integration from scratch in production. D. Embed endpoints directly in orchestration logic. Answer. Correct answer. B. Explanation. Using connection properties with variable substitution allows environment-specific endpoints to be set without altering integration logic, streamlining deployments. Manual reconfiguration is error-prone. Creating integrations from scratch wastes effort and risks inconsistencies. Hard-coding endpoints in orchestration is inflexible and violates OAK deployment best practices. This method ensures consistent promotion across environments. Question 14. By evaluating a failing BB integration, Raj discovers that partner-specific value mappings are causing mismatches. Which OAK feature should he use to manage these mappings centrally? A. Groovy scripts embedded in the integration. B. OAK lookups configured for partner-specific values. C. Static mapping tables in an external database. D. Hard-coded mappings in adapter configuration. Answer. Correct answer. B. Explanation. OAK lookups centralize partner-specific value mappings, making updates easy without code changes. Groovy scripts add complexity and require redeployment for updates. External DB mapping tables add dependencies and latency. Hard-coded adapter configurations limit flexibility. Lookups follow OAK maintainability and governance best practices, especially for multi-partner BB scenarios. Question 15. While examining API gateway policies, Alina wants to ensure that incoming requests are limited to prevent abuse without blocking legitimate traffic. Which policy should she apply there? IP whitelisting. B. OAuth 2.0 authentication. C. Rate limiting policy. D. Custom header validation. Answer. Correct answer. C. Explanation. Rate limiting controls the number of allowed requests in a time window, preventing abuse while maintaining service for legitimate users. IP whitelisting restricts access but doesn't manage request volume. OAuth 2.0 secures access but doesn't prevent excessive calls. Header validation adds basic checks but no traffic control. Rate limiting aligns with API Gateway best practices for performance and protection. Question 16. The primary reason for using the OAuth connectivity agent is A. To allow secure on-premise to cloud integrations without inbound firewall changes. B. To increase the maximum payload size for REST calls. C. To store files temporarily during integration runs. D. To encrypt data at rest in OAuth. Answer. Correct answer A. Explanation. The connectivity agent enables outbound initiated, secure communication from on-premise to cloud, avoiding inbound firewall exposure. Increasing payload size is unrelated. File storage is handled via staging or object storage, not the agent. Encryption at rest is a separate security feature. This component is key for hybrid architectures where direct inbound cloud calls are restricted. Question 17. In contrast to synchronous flows, asynchronous OAuth integrations are more suitable when A. Responses are required instantly by the client. B. Long-running processes or delayed responses are acceptable. C. Integration logic must be executed in strict sequence. D. Data must be transformed before returning to the caller immediately. Answer. Correct answer B. Explanation. Asynchronous patterns excel in scenarios with long-running tasks or when immediate responses aren't needed, avoiding timeouts. Instant responses demand synchronous flows. Strict sequencing can be achieved in either pattern, but async may add delays. Immediate transformations with return to caller are synchronous by nature. Pattern choice should match SA and process characteristics. Question 18. When analyzing file handling in OAuth, which method is optimal for processing very large files that exceed the adapter limits? A. Break the file into chunks using the stage file action with segment read. B. Increase the adapter's max file size limit via configuration. C. Compress the file before transfer to bypass limits. D. Store the file in object storage without processing. Answer. Correct answer A. Explanation. Stage file with segment read enables chunk processing within OAuth limits, ensuring large files are handled without failure. Adapter limits are fixed. If configuration changes won't bypass them. Compression may reduce size, but requires decompression logic and may still exceed limits. Object storage is useful for holding files, but doesn't address the processing requirement. This is the standard large file handling approach in OAuth. Question 19. In summary of monitoring capabilities, which OAuth feature allows business-level tracking of integration performance over time? A. Integration insight. B. Connectivity agent logs. C. Target application audit logs. D. Data mapper validation logs. Answer. Correct answer A. Explanation. Integration Insight provides KPIs and dashboards for business transaction tracking, supporting performance optimization. Connectivity agent logs are connection-focused. Target app audit logs capture downstream activity only. Data mapper validation logs assist in transformation debugging, not ongoing performance analysis. Insight enables both operational and business-level visibility, aligning with OAuth monitoring strategies. Question 20. With the advent of Groovy scripting in OAuth, developers can A. Replace all integration logic with custom scripts. B. Implement complex transformations in conditional logic not natively supported. C. Modify OAuth platform security settings. D. Avoid using adapters altogether. Answer. Correct answer B. Explanation. Groovy scripting complements OAuth by enabling transformations or logic beyond native mappers without replacing core integration structures. It cannot alter platform-level security settings. Avoiding adapters removes benefits like protocol handling and simplified connectivity. Using Groovy exclusively for all logic is inefficient and against best practice. It should extend, not replace, native capabilities. Question 21. In the absence of a public API, a Marisol's team must integrate with legacy on-premise application using OAuth. The application supports only local database connections. Which approach is best? A. Use the database adapter with the connectivity agent. B. Implement REST adapter with CUTM-ADC. C. UFTP adapter for CSV exports and imports. D. Create SOAP endpoints using third-party gateway. Answer. Correct answer. A. Explanation. The database adapter with the connectivity agent securely connects to on-premise databases without exposing them publicly. REST with DDC bridge adds unnecessary complexity and security concerns. FTP with CSV is batch-oriented, not suited for real-time needs. SOAP endpoints via a third party require extra infrastructure and don't leverage OAK's native capabilities. This method aligns with secure direct hybrid connectivity best practices. Question 22. Historically speaking, integrations often hard-coded transformation logic causing maintenance issues. Which OAK feature eliminates redeployment when mappings change? A. Groovy scripts stored in integrations. B. Lookup tables managed within OAK. C. Target system configuration overrides. D. Environment-specific connection properties. Answer. Correct answer. B. Explanation. OAK lookups allow dynamic value mapping changes without modifying or redeploying the integration, improving agility. Groovy scripts require redeployment for changes. Target system overrides don't adjust integration mapping logic. Environment-specific properties manage connection endpoints, not data mapping rules. Lookups are key governance and maintainability feature in OAK. Question 23. When evaluating the merits of synchronous versus asynchronous integrations, which scenario clearly benefits from a synchronous design? A. An e-commerce checkout requiring instant inventory confirmation. B. End-of-day data consolidation from multiple sources. C. Payment gateway authorization calls. D. Real-time fraud detection service queries. Answer. Correct answer. B. Explanation. End-of-day data consolidation can run without immediate responses, making asynchronous processing ideal. E-commerce checkout and payment gateways require instant replies, favoring synchronous flows. Real-time fraud detection also demands low latency. Async frees up resources, handles longer processing, and avoids client timeouts for non-urgent batch operations. Question 24. From a historical standpoint, Ravi notices multiple failed invocations due to transient network issues when invoking external SOAP services. Which is the most resilient approach? A. Replace SOAP calls with REST. B. Implement a fault handler with retry and exponential backoff. C. Disable the integration temporarily. D. Use synchronous flows to ensure reliability. Answer. Correct answer. B. Explanation. Retry with exponential backoff is a resilient strategy for handling transient failures, improving reliability without overloading services. Switching protocols from SOAP to REST doesn't inherently solve transient issues. Disabling integrations halts business processes unnecessary. Synchronous flows don't guarantee reliability. They can worsen issues by blocking processes until timeout. Question 25. While it is true that OAK supports multiple adapters, which scenario best demonstrates the value of the stage file action? A. Streaming small JSON payloads to REST services. B. Processing large batch files in segments before transformation. C. Invoking OAK Cloud APIs directly. D. Managing user roles in OAK. Answer. Correct answer. B. Explanation. The stage file action enables reading and processing large files in segments, avoiding adapter limits and memory constraints. Streaming small JSON payloads doesn't need staging. Direct OAK Cloud API calls are unrelated. Managing user roles is an administrative task outside stage files' purpose. Segment processing aligns with OAK's large data handling capabilities. Question 26. As a result of our API gateway audit, we must prevent excessive usage from a single client while keeping the service available. Which policy should be applied? A. IP whitelisting. B. Rate limiting. C. OAuth 2.0 token enforcement. D. Message transformation. Answer. Correct answer. B. Explanation. Rate limiting controls request volume per client, preventing abuse without complete access denial. IP whitelisting restricts by source but doesn't manage volume. OAuth secures authentication but doesn't regulate frequency. message transformation changes payloads but doesn't address abuse. Rate limiting aligns with API Gateway's traffic management best practices. Question 27. The common thread among high-performing OIC integrations is minimizing transformation complexity. Which design choice supports this? A. Perform heavy transformations in target applications. B. Chain multiple integrations for stepwise transformations. C. Consolidate mapping logic into a single optimized data mapper. D. Avoid transformation and pass raw data downstream. Answer. Correct answer. C. Explanation. Consolidating mapping logic in a single optimized data mapper reduces processing overhead and improves maintainability. Offloading transformations to the target app can create coupling issues. Chaining multiple integrations adds latency and operational overhead. Passing raw data risks incompatibility and increases downstream burden. OAK best practices favor centralized, efficient transformations. Question 20. When presented with a requirement to capture and track key business milestones in an order process, which OAK feature provides business-level visibility? A. Integration insight. B. Audit logs in the target system. C. Stage file read reports. D. Groovy debug logs. Answer. Correct answer. A. Explanation. Integration insight allows defining business milestones and tracking them visually, aiding both operational and strategic analysis. Target system audit logs are limited to that system's scope. Stage file read reports show only file processing details. Groovy debug logs are for technical troubleshooting, not business API tracking. Insight aligns with OAK's business monitoring capabilities. Question 29. Across different scenarios, which advantage does the OAK connectivity agent offer over direct public internet connections? A. Reduced payload size for cloud services. B. Secure outbound initiated connectivity avoiding inbound firewall changes. C. Automatic message translation between XML and JSON. D. Faster execution times for all integrations. Answer. Correct answer. B. Explanation. The connectivity agent enables secure outbound connectivity from on-premise to cloud, avoiding inbound firewall exposure. It doesn't reduce payload size automatically. Message format translation is handled by mappers, not the agent. Execution speed depends on many factors. The agent's advantage lies in secure hybrid integration, not guaranteed speed increases. Question 30. The effectiveness of Groovy scripting in OAK is best demonstrated when A. Replacing adapters entirely. B. Implementing conditional logic or transformations beyond native mapper capabilities. C. Modifying platform-level access controls. D. Avoiding orchestration design altogether. Answer. Correct answer. B. Explanation. Groovy scripting extends OAK functionality with complex logic or transformations not supported natively. It cannot replace adapters, which handle protocol and connectivity. It cannot alter platform-level controls. Avoiding orchestration design removes valuable integration capabilities. Proper use is as an enhancement to existing OAK tools, not a replacement.